Let's do some practice with variables, symbols, and units. And here I have a little table where I am writing out a variable name. I've got 3 of them. I've got a symbol to represent each one, and then their corresponding units. So Zamble has the symbol Z and has units florbs. The variable Vim has the symbol capital V and has the units quandle. And variable Zan has the symbol capital X and has units luns. Now we're going to look at some complex combinations of all of these in some equations and see if you've really mastered this skill. But before we do that, let's just go back to kind of a simpler idea to make sure you really understand the process. So here you can see we have a similar idea, variable, symbol, and unit, and we have 2 variables, income and time worked, and they have symbols capital I and lowercase t and units of familiar dollars and hours. Now take a look at this mathematical model that represents the income that someone makes if they work for a certain number of hours. And I'd like you to just pause the video and see if this will work. Do we have all the correct units, and would this produce an income for a certain number of hours worked? So go ahead and pause and see if there are any mistakes. All right, well, I hope you found the mistake. If you imagine that we worked for a time of 0 hours, didn't work at all, well, this whole term here would cancel out, and then we'd be left with this 100 left over, but 100 what, right? That would need to have units to make this consistent. This is income, and at the end of the day, income has to be in units of dollars. So we should have $100 here. Now, what would the interpretation of this be, of course, in the real world? Well, it would be perhaps if you got hired for a job and you were given some signing bonus or something like that, and you hadn't worked at all, no time, but they just gave you a $100 bill. Right, so this would now be a nice mathematical model to represent your total income as you continually work a certain number of hours. So now I've circled these units here that are attached to this number 20. And it's probably familiar to you that that's the amount of pay you'd receive, $20 for every 1 hour, or $20 per hour. Seems intuitive. This is a familiar context, but when we remove the context with these nonsense words, it becomes a little bit more challenging, and that'll indicate if you've really got the skill of how to do all of this, right? So let's go through and just see how exactly you could test to see if whatever units you choose to be here are actually indeed the correct units. And as you do more of these and you get practice with it, you can just look at the symbols in the equations and figure out the units pretty easily. But in the beginning, it's nice to go and test. So for example, we would say, let's say we worked for 3 hours. So do a hypothetical amount of one of the variables. In this case, we only have one of them, which is time to plug into over here. We can come along and plug in for that and see what happens. All right, so we plug in for 3 hours. And importantly, you know that these units are correct up here because when you plug in an actual number and you start doing some cancellations with the units, everything is consistent. We now get $20, sorry, $60 over here. So 20 times 3 plus $100, which is left over from that plus sign, and then we get a final result of some number of dollars plus another number of dollars. That's consistent. That follows the rules of addition here, like units plus like units, and we get $160, which is exactly what the units of the variable income is. So that's a simple way. Give test values for the variables in the equations with the units and see if it works out to be consistent as it does here. Now let's look at a more complex example with our nonsense words. So here's a practice problem. Take a look at the table and then take a look at this equation and see if you can figure out what units need to be attached and labeled on the number 5 and also what units need to be attached on the number 7. So this is kind of like the next level up from the familiar context, and then we'll do an even more challenging one next. Go ahead, pause the video, and see if you can get this right. All right, let's take a look. If x is equal to 0, then you just have the number 7 over here by itself, and that has to have units of florbs, so they would be z is equal to 7 florbs, similar to our last example. Now in parentheses here, we're going to need to have a cancellation, and at the end of the day, we have to have units of florbs. So there better be florbs in the numerator in our units here. And then when we plug in for x, which will be a certain number of luns, and you could always do a test example. For example, we might do something like 3 luns. Well, that's going to need to cancel out with something in the units in the denominator over here. So we should have luns here. And you could do a test again, just like we have done. So plug in 3 luns and then make sure everything works out. So let's just do it quickly. So you get 5 florbs for every 1 lun multiplied by 3 luns plus 7 florbs. And let's see if the cancellation works. That luns, or I'm using lun and luns, it's okay. We'll cancel there, and you get 5 florbs plus 7 florbs is equal to something that makes sense, which is 12 florbs. So it all works out. We go check our table, and we see florbs. Well, that's the unit for Zamble, and we're consistent. We're good to go. Perfect. Okay, so that's kind of a medium level one. Probably easy for a lot of you, but when you take away the context, it really forces you to make sure you understand it. Now let's try just a much more challenging one and see if you really got it. Okay, so here it is. And I've introduced you to now squared. We're squaring a variable. So how's that going to play a role? And then we have some similar ideas. So you need to figure out the units here and then the units over here. So pause the video and see if you can get this one. Let's take a look. Zan has units of luns. So we know this 4 has to have units of luns. And then over here, whatever happens in this parameter, 3 times v squared, that whole thing has to reduce down again to whatever the variable for Zan, whatever the units for Zan is, and that's units of luns. So we better have luns at the end of the day. So we're going to need that in the numerator. And then we're going to have to cancel out the other units coming from v squared. So we look at v in the table, and we see Vim here has units of quandle, but we're squaring that. So here we're going to get some number of quandle squared. Let's do an example. And we'll come up here and hypothetically make up that we have a Vim value here of 5 quandle. I'll just use QU for quandle for the units there. And let's just plug into the equation, imagining we were trying to solve everything out, even though we don't have all the units correct quite yet. So we'll have luns up there. We still don't know what goes below that. Multiplied by, okay, well, let's square this value, 5 quandle. So that would be 25. But here's the key idea. You got to square the units as well. So we get 25 quandle squared, and then we have plus 4 luns left over there. All right, so hopefully you can start to see it now. We're almost there. We've got luns here. That's the unit for Zan. That works. And then we got it up here. But if we were to multiply this out as it stands right now, we would get the wrong answer. For example, I'll just write that. If we were to multiply this out, you'd get 3 luns, or 3 times 25, which is 75. So let me just write the correct math. You get 75, and the units would be luns multiplied by quandle squared plus 4 luns. Clearly, you can't do that. That's like adding apples and oranges in this equation. You can only add like units, right? So if we ignore that, let me just erase it all and just think, how do we get rid of those quandles squared? Well, we can put it right here in the denominator. Quandle squared would go down there, and we should now be able to get some nice cancellations out. And let me just change the color so it's all the same color. Okay. All right, perfect. And then I'll use the red pen to cancel it out. So now you can see that set of unit, quandle squared, will cancel out with this. And now we'll have everything to be consistent once again. So we would get 75 luns from that multiplication plus 4 luns is equal to 79 luns. And there's our answer, and we did it. All right, last one. Much more challenging here. So go ahead and pause the video and really work this one out. See if you can get it totally right. Do some test cases like I've done, and you'll get some sense of if you've mastered this. Pause the video. Okay, so let's take a look. Key skills, only add like units and look for unit cancellations. So let's do those things. So we can only add like units at the end of the day. This has to have units of luns. So over here, we'll make sure we have that. Luns, 3 luns. Adding to, well, this whole term 5 times z over v squared, that better turn into a certain amount of luns. So we'll definitely need luns up in the numerator. And now we just have to look for some unit cancellations. So we see Zambel is in the numerator. And a key mistake people often make is they think that they would need to put the units of Zambel, which are florbs here, right there. That's wrong. That's not going to work. It's not a pattern matching thing where you're visually like carrying over something like that. You have to think about plugging in for a certain number of Zambels, which would have units of florbs, and then some cancellation happening, which we'll see at the very end. So we would need to have florbs here on the bottom to cancel out when we plug in up here for a capital Z. And likewise, we would need to have some cancellations for the Vim variable. It's squared, and so quandl squared, that would be the units, and that would need to cancel. So we would have quandl squared up here. So we'd get 5 luns times quandl squared divided by florbs, and then everything should work out. So pause the video now and plug in some test values for both Zambel and Vim and work it out and see if at the end of the day you get a certain number of luns plus 3 luns. And if you do, then you've done it right. We'll take a look in a second together. Pause and try it yourself. All right, so I've made some test values. Got Z is equal to 8 florbs and V is equal to 2 quandls. And we'll plug those values for those variables in here. Remember, variables are these placeholders for certain values that we can plug in, and units are labels attached to those values. So we'll plug in. So 8 florbs, put that up top. Okay, there we go. And then on the bottom we have 2 quandl. But that's squared. All right, so now I have this here, and we could work it out. And if you haven't worked it out, pause and now try to work it out with all the units plugged in and see if you can cancel everything out, and we'll do it now. All right, so we plugged in the values here, and the key thing to watch out for is you have to square these 2 quandls, so that would give you 4 quandls squared. And now let's just do all the unit cancellations and see if we got it right. All right, well, we've got florbs up here. Those will cancel with those. These quandls squared will cancel with this quandl squared. And we have luns left over in this giant multiplication here. And it looks like if we were to do all the math right, we would get 5 multiplied by 2. So 8 over 4 is 2. So 5 times 2 is 10. But 10 what? Well, 10 whatever's left over with units, and that would be luns, plus the 3 luns over here. And that's going to give us 13 luns. So there's the right answer. Hopefully you got that, or at least with my test values. You might have made up your own, but you got the fact that we were left with units of luns. All right. Now that took a good amount of work to plug in all the numbers every time, and it would be nice if there was an easy way, right, to kind of see this. And that's when you start to build up higher abilities of abstract reasoning, where you don't have to kind of plug in all these values and do all that cancellation, because you know how it works and you can just think abstractly like that. So to get there, look for some patterns. I mean, the first pattern obviously is that if you've got a plus sign over here, then whatever is here with just a plain number, that better have the units of the thing all the way on the left-hand side. So you can just write that in easily. And then here, when you have some type of complex expression where you're having a division and a squared or maybe a square root or whatever, you can see that you're just going to be doing cancellation. So if you got a v squared on the bottom for the variable, then you're going to have some units up top on the numbers associated over here that cancel that out. So quickly then you can see that you're going to have a quandl squared over here. You've got Zambel up top, and that has units of florbs, so you're going to need florbs on the bottom to cancel out when you ultimately plug in for a certain number of Zambel for the variable Zambel. And then, of course, this whole multiplication better give you luns, so you're going to need luns here in the numerator, and that gets multiplied like that. And now we have it, and we just did it real quick without having to plug anything in because we see this abstract pattern now that makes sense. All right, so there you have it, some nice practice with variables, symbols, and units. And you want to keep reinforcing these skills as you continue to learn physics. And you want to make this automatic so you don't have to think about it, and so you can use your mind to think about the harder conceptual ideas that we'll see in physics. All right, take care, and we'll see you in the next video.